In 3B, there's a couple of questions people were uh, asking about or struggling with, and one was the Trail of Tears number 50. It says, estimate the length of the northern or other route, land route, upper green line from Charleston to Lackawanna. Well, when I printed this, it didn't come out in color, but so I had to go back and look, and here's Talakwa, and it was this line that goes down to here and then goes along here to Charleston. And if that's 50 miles, let's see, I need to figure out some way to measure 50 miles. And so, let's see, if I take my pencil, I'll just do from the where the wood starts to the wood here. That's this piece. And if I'm just estimating, I can move it along. In fact, I'll just eyeball that. That is about to there. Looks like Fayette's about 50 miles, 100, 150, 200, 250, 300, 350, 400, 450, 525 miles. And I'm pretty far off, so I would maybe round this just to around 500 miles. Okay. And then there was a question on the interstellar travel, and it said the fastest spaceships launched to date travel from the Earth, traveling away from Earth, go at 50,000 kilometers per hour. And so we're supposed to look at how far is it to Alpha Centauri. And if I were to click on that there, it tells me, and I've got to get it back up here on my computer so I can look at it. It says Alpha Centauri, based on example 8, is, oh, what's going on here? Distance to stars. Here we go. Alpha Centauri is 4.3 light years. But how far is a light year? Well, a light year is, what that means is how far will light travel in 1 year? Well, light's pretty darn fast. Light travels to the moon in 8 seconds. So this is a lot further than the moon, and it takes 4.3 years for the light to get from Alpha Centauri to us. And light travels at a speed of approximately 9.46 times 10 to the 12th kilometers. This is according to the book. If you click on the length, kilometers in 1 year. So Alpha Centauri is 4 times that away. So if I take 9.46 E12 times 10 to the 12th times 4.3 light years, it's 4.067 times 10 to the 13 kilometers away. So this times this is 4. Got to get back here so I can see what I'm doing. make sure you can see it, 4.0678, 4.0678, 4.7 times 10 to the 13 kilometers. So it's that many kilometers to Centura. And if you're traveling at 50,000 kilometers per hour, we want this means 50,000 kilometers in 1 hour. And we want the kilometers to cancel, and we want hours. So we want to write this the other way around. So we're going to write 1 hour. The ship will go 50,000 kilometers. Kilometers cancel. So we need to take this and divide it by 50,000 to find out how many hours it would take. So I have that answer in here, and I have to divide it by 50,000. And I get a really large number of hours. So at 50,000 kilometers per hour, one of the fastest spaceships we have, it takes 306, so 814 million hours. And if we want to talk about that in maybe days, we'd divide it by 24, and it would take us, let's see, 33.9 million days. And if we wanted to go further, how many years? We'd take this divided by 365, and it would take us 900-ish years in that ship. So, how realistic the speeds that we can travel our spaceships right now is it that someone able to travel to Alpha Centauri? And not very likely that somebody will live 92,900 years. Even if we can figure out how to put the life on life support, hold so you don't age for a long time, you're still probably going to age in 92,900 years. Not very realistic that we'll be traveling to Alpha Centauri until we can get that speed up to closer to the speed of light. And even if we got it close to the speed of light, it would be a little bit more than 4 years to get there. But the speed of light is really, really fast. And there's Einstein and some other people that have talked about how going close to the speed of light changes time and whatever, and things get really weird when you get close to the speed of light. We think. We don't even know because we've never been there. Okay? 3B, number 60, asked, the prison population in the United States in 2020 was 2.3 million. So that's 2,300,000 people in the prison. And they want to know how many stadiums. Well, one stadium, they're saying, holds, and we want the people to count. So, and that's 60,000 people. So the people would cancel. So we got to take this times 1 divided by 60,000. So that's 2.3 million, 2.3 double E times 10 to the 6 for million. So that's that number divided by 60,000, and it would fill, the number of people that we have in prison would fill 38.3 or 38 and 3333 is a third stadiums. I think, let's see, football stadiums in the United States, there's not even 38 pro football stadiums in the country. And so it'd fill, all the prisoners could fill all of the stadiums for game day in the NFL, and still that'd be only probably about half of them. So anyway, a lot of prisoners.